All right, so what we're looking at here, okay? We want to find the intersection of those two lines, right? We want to find the intersection of those two lines. That intersection point is the circumcenter. Do you remember last year? If I would have given you, or Miss Coles, or whoever your math teacher was, would have given you those two black lines in the coordinate plane, you use systems of equations to go find the point of intersection, right? The x comma y where they cross. But last year they gave you equations for those two lines, okay? Or if we, let me put the third one in here real quick. Okay? We could find the intersection of that third perpendicular line. All right, so maybe we're looking at those two lines, and we have the equations of those two lines, and we try to find the intersection of those using systems of equations, right? So each of those black lines had a y equals something, correct? And we went through the algebra to solve those. That's what we're going to do today. But we don't have any of the y equals stuff yet. We have to generate that on our own using our knowledge about Algebra 1. Okay? So I'm going to look at those two perpendicular bisectors. Okay? And I'm going to look at just one at a time. So let's look at that one. I have to come up with the equation of that black line. Okay? Now, when you come up with an equation of a line, what are two things that you absolutely need for any equation? Finding out why we do not, or Mr. Fay does not let people just sit where they want to, right, Evan? Write down? Okay? Yeah. Concentrate on this. This is what we're talking about today. Okay? If I want to come up with the equation of a black line, okay, what is one thing that I absolutely need to know for any equation of a line? Slope. I need to find the slope of that black line. Okay? How many points do you need to find slope? Any line, how many points do you need? 2. When I look at this thing, do I know any points that are on that black line? And that I can be confident in? None. Okay? None that are highlighted right now. But by definition, that black line is a perpendicular bisector. It is a perpendicular bisector of that line, isn't it? If it's a perpendicular bisector of that line, what's it go through for that line? It means they intersect at a right angle, but if that black line is the perpendicular bisector, what point does it pass through on this line here? The midpoint. So is the midpoint of that purple line, is that a point on my black line? Yes. Do we have the tools to find the midpoint of that purple line? Yes. Yeah. So we're going to take and find that midpoint. Okay, so all I have to do, midpoint of that purple line, is add those x's together, divide by 2, right? That's a good idea, yeah. Okay, I'm going to add my x's together, divide by 2, and that's going to give me that coordinate, x coordinate of that midpoint to be 3. We'll do the same thing for my y's, right? 10 plus 4 gives me 14, divide by 2 gives me 7. Okay, so 3 comma 7, I absolutely know 3 comma 7 is on that black line. Okay, is that all right, everybody? Now, again, I need a slope and a point to come up with an equation of a line, right? I now have the point that I need for the equation of that black line. But I don't have the slope of that black line. Again, how many points do you need to find slope? 2. I only have 1. Okay? But isn't there a relationship between that black line and that purple line because it's a perpendicular bisector. What's the relationship between two segments or two lines that are perpendicular to one another for their slopes? Do you have a right angle, but what's the relationship between their slopes? Opposite sign reciprocal. So, can I find the slope of the purple line? Can find the slope of the purple line. So let's find that. So the slope of AC, the purple line, is going to be what? 10 minus 4 over 2 minus 4. So we get 6 over negative 2, so I get negative 3, right? So the slope of the purple line is negative 3. What is the slope then of the black line? 1/3. Okay? So slope of this black line is 1/3. You now have the two components that you need to create the equation of that black line. Does that make sense? Now I found the slope of that black line indirectly. Okay, meaning that I did not use 2 points off that black line to come up with the equation, right? Or to come up with the slope value. I used a relationship between the purple line and the black line. I knew the purple line slope, so I used that relationship then to find the black one. Okay? I never directly used points that were on that black line to find the slope. Okay? A lot of math is that way, where we can use indirect relationships to provide us with a 100% accurate value. Okay? So, finding the equation of that line then. You've got two options. You go y minus y1 equals m times x minus x1, where x1 and y1 is a point that you know 100% is on your black line. What point do we know 100% is on our black line? 3, 7. That's x1, y1. Do you know the slope of that black line? The black line's 1/3. The slope of this one was negative 3. So I'm going to go y minus y1 is equal to my slope of 1/3 times x minus x1, which was 3. All right, now, we do end up with fractions here, but I think they're going to multiply out to be pretty nice, at least for writing the equation of this thing. Every time I use, remember this is the called point slope form. We then, in order to use this and make it meaningful to us, we want to transfer it into slope intercept form. So that means I'm going to distribute that. So I get y minus 7 is equal to 1/3 x. 1/3 times negative 3 is negative 1, right? And now I'll add 7 to both sides. That is the equation of that perpendicular bisector. Okay? If we use GeoGebra as a nice tool for us, I can just type in 1/3 x plus 6. Hit enter. Come on. Okay? And you see that nothing new showed up, right? It's because it is graphing on top of the line that's already there. Okay? You actually saw it maybe kind of highlighted. It bolded in that line a little bit, right? Okay? So 1/3 x plus 6 is the equation of that black line. Set that aside. Okay? I'm going to erase some information here. I'm going to set that equation to the side. Y equals 1/3 x plus 6. Because that was just one perpendicular bisector, right? I need 2 to find the intersection point. So I'm going to look at that one. Okay? That's the perpendicular bisector of AB, right? You could just do it on top of, so you'd eventually maybe have that picture there. Because that's ultimately what we're looking for. Ultimately, we're going to have them both together so we can find that one point there where they cross. But I like to just show you one at a time so you're not visually confused with what we're talking about on the smartboard. So the argument is, if I can do what we just did, if I can find this 1/3 x plus 6, that process, it's just repeating the entire thing, but now looking at the perpendicular bisector of the blue line. Okay? So what do I need to find the equation of that perpendicular bisector? I need a point and a slope, right? Okay, the easiest thing I think is to find the point. Okay, what is this point right here is the what of AB? It's the midpoint, right? So we should be able to add our x's, divide by 2. So 2 plus 12, 14. 14 divided by 2 gives me 7. 10 plus 4, 14 again, so 7. So my ordered pair (7, 7). Okay. Now I need the slope of that black line, right? But we can't find the slope of the black line because we don't have 2 points on it. So we find the slope of the blue one. Okay. Find the slope of the blue one would be taking 10 minus 4, so y2 minus y1 over x2 minus x1. So 2 minus 12. So I've got now 6 over negative 10. Yes? Say it again. We're finding the slope of the blue line AB, yes. Is that what you're... Okay. So 6 divided by negative 10, so 6, 2 goes into that, right? And 2 goes into 10. So the slope of the blue line is negative 3/5, right? Negative 3/5. So what is the slope of that black line right there? 5/3. You negate the blue line slope, and then you change the numerator and denominator, right? You find the reciprocal. Okay? All right, so now that we've got those things, these two components right here, the 5/3 and a 7, 7, that is going to be the information we use to write our equation. Y minus y1 equals m times x minus x1. Okay? I think that's the best approach to use, that formula. If you're a person that wants to use y equals mx plus b, I'll show you in a minute how you can do that. But I like that because it's insightful on what goes in what spots. The y1, that was the point off the line, the y value of the point off the line. My m is 5/3, and x1 is the x-coordinate of the point that was on that line. So I get that. So now, that's point slope form. We want to change it to slope intercept form. So we're going to distribute the 5/3. It's the same process that we did in the last equation. We distribute that. I get 5/3 x. And now it's going to be minus. So when I distribute to that 7, it's a fraction times a fraction, right? Multiply top times top. So it gives me 35 up top. 3 times 1 gives me 3 on the bottom. I do not want to change either of those to decimals, because 5/3 as a decimal is 1.666666666 repeating, right? And at some point, if I cut that off and I just write it as 1.66, then I'm not going to find the right circumcenter, because that's not the right equation for the line. Does that make sense? Okay, because we have rounding error, and that's a problem. So we leave them as fractions. This is y minus 7 right now. I have not moved that 7 over. Okay, so I moved that 7 over through addition, correct? Add 7 to both sides. It's going to be y equals, now 5/3 x minus 35/3. But now I got to add 7, right? Does that make sense to everybody? Writing it that way? Now, the 35 thirds and the 7, those are like terms, correct? They're the ones that are non-variable. We need to condense those. We need to simplify those. Okay? How do I add two fractions together? What do I need? I need a common denominator. What's the common denominator going to be between these two terms? 3. So I put a 3 there, and I put times 3 up top, right? So what's that 7 going to turn into? 21 thirds. Okay? So 21 thirds is still 7. Would you all agree with that? So now what's negative 35 plus 21? 14. Negative 14, right? Okay? So we're going to get y equals 5 thirds x minus 14 thirds. That's the equation of that second perpendicular bisector. Okay, so if you remember what we did last year, okay, going through last year, the question last year was this. If I were to give you see here, let me clean some stuff up real quick. Last year I gave you that stuff. I gave you that picture in the coordinate plane. Gave you that picture in the coordinate plane. And told you that this equation right here was y equals 5 thirds x minus 14 thirds. This equation here was 1 third x plus 6. Okay? What did we do? If those two things are going to intersect, that point right there is going to be an x comma y, right? At that point, this y value is the same on that line as it is on that line. Does that make sense? So that means this y value right there is the same as that y value right there. If those are the same, doesn't it tell us that 1 third x plus 6 is the same thing as 5 thirds x minus 14 thirds? If these y's are the same, then those two things are the same, right? Is that okay with everybody? Can you solve that equation? That equation, one variable. What would you think about multiplying everything by in order to solve that equation? Multiply everything by 3. So it's going to give me x plus 18 equals 5x minus 14, right? Can I solve for x now pretty easily? Okay, so a lot of these guys are going to be ugly. They're not going to be real nice numbers. They'll probably be fractions. Okay? If I subtract the x's from both sides, I get 4x here. Add 14 to both sides, that's going to give me 32. This one actually turns out to be kind of nice. X is going to be what? 8. Okay? Now, if x is 8, do I have an equation that allows me to solve for y knowing what x is? Don't these two equations tell me what x is, or start telling me what y is when I plug in x? Which one of those equations do you want to use? I would use the top one. Does it matter? No. Okay? I would use the top one because there's only one fraction there, right? So say y is equal to 1 third of x. Well, x is now 8. And then we'll add 6 to that. What's 1 third times 8? As a fraction, 8 thirds, right? Plus 6. Okay, well, if I want to add 6 to 8 thirds, what do I need? Common denominator, right? So it'd be 18 thirds, right? That 18 thirds is still 6. What's 18 plus 8? 26. Okay? Does 26 divide by 3 evenly? No. Okay? So my y value is 26 thirds. So x is 8. Y value, 26 thirds. That should be, if we type that in, if I go 8 comma, 26/3. It should be that point of intersection, right? That point of intersection, put the triangle back in here, should be the circumcenter, meaning that that point is going to yield that circle right there, that when I go from the circumcenter to one vertex on my triangle, that circumscribed circle goes through all 3 points on my triangle, right? Okay. Would you agree that there's a lot of algebra there that we were using from last year? Okay. Now, something that I think is probably kind of important to reflect upon is think about how you navigated through algebra last year. Did you navigate it through by yourself, on your own, working diligently to be successful in that class, or did you use other people's work? Okay? Because if you use other people's work, you probably didn't learn it very well, right? Keep that in mind, because this stuff that we're learning now is going to be used later on in other courses, right? What you learn in geometry is used in Algebra 2. What you use in Algebra 2 is you're using pre-calculus. What you use in pre-calculus, right? If you're going to allow other people to do the work for you, you're never going to learn that stuff, and you're always going to be in a situation where this creates anxiety and stress, and it's very difficult, right? But if you do the work on your own and learn it on your own, okay, now you can use other people to help you, but don't use their work. Does that make sense? You all see what I'm saying here? Okay? You won't have that angst and that anxiety all the time with this stuff. We're going to continue to do this. We'll see more and more examples of this. But my hope is that you realize that the algebra that we did last year is very, very important to us. Okay? It's what drives all of mathematics. Okay? There's no way around it. I wish there was. I wish we had a geometry class where we didn't have to do this stuff. But there isn't. Okay? No new homework tonight. Just make sure that you do kind of continue to work through that assignment that's due on Monday. The algebra review assignment is due tonight, so make sure you finish that up.